So we're going to talk about the humoral immune response of specific immunity, of adaptive immunity. So this is the ones that are using the B lymphocytes. This is antibodies and how antibodies work. So it starts out with the antigen challenge. The antigen is in your body, attached to a pathogen usually. And what happens is that the antigen, the pathogen with the antigen on it, encounters a naive, mature lymphocyte. Normally this happens either in the spleen if it's going around in the blood, or in lymph nodes if it's traveling through the lymph. It may happen in the tonsils, may happen in the digestive system, in the appendix, or Peyer's patches or something like that. But generally speaking, lymph nodes is probably the most common thing. Now, this is a raw antigen. This is the antigen still attached to the pathogen, and this is found in the interstitial fluid, not found in the cells. It's not a virus that has gone into a tissue cell yet. So bacteria fall into this, fungus, any sort of pathogen, anything with an antigen on it that's found interstitially. Now, if the naive but immunocompetent lymphocyte that it runs into is a B cell, then you get this humoral response that will ultimately end up as the production of antibodies. Now, when the B cell, when the B lymphocyte is activated, one of the things is that if it started producing antibodies right then and there, there's probably far more pathogens than there are naive immunocompetent B cells of that specificity for that antigen. You wouldn't be able to produce enough antibodies to have a very large impact. What you need is more lymphocytes that are exactly the same, so that you can mount a big response. So what happens is that the B cell binds with the antigen. The surface receptors on the B cell surface actually lock into the antigen, and then there's endocytosis of the antigen and receptor joining, right? And then that stimulates the B cell to start to undergo mitosis and make copies of itself. We call this cloning. What happens is it makes all kinds of copies of itself that have the exact same receptors. The ones made in the bone marrow don't get their receptors right away. The ones that are cloned this way end up with the same receptor as the parent cell, and that's the receptor to the antigen that has just been encountered. So you make a whole bunch of copies of the specific lymphocyte, B lymphocyte, that you need for this specific antigen. Now, most of these clones morph, they change. They grow endoplasmic reticulum because antibodies are really proteins, and proteins are made on rough ER, on the ribosomes of rough ER. So before you can make a lot of antibodies, you better make a lot of rough ER. They become little factories for antibodies. But now they're not the same as the B lymphocyte, so we call them plasma cells, as in endoplasmic reticulum. And they start to make antibodies. They start pumping them out. And the rate that they pump them out at is a couple of thousand per second for the better part of a week, 4 or 5 days. They make huge numbers of antibodies, and that's each clone. There may be thousands and thousands and thousands of clones. You're making antibodies in the millions per second. Huge numbers. And then these antibodies circulate in the blood or your lymph, and what they do is they stick to the antigens on the pathogen, and they basically target, and it's like they're painting bullseyes on the pathogens. They are targeting the pathogen for destruction. They're making it easier to destroy the pathogen. Now, not all of the clones end up becoming plasma cells. They don't all grow into plasma reticulum. A lot of them actually just stay as B lymphocytes. And they in turn are called memory cells. And their job is to be ready for the next round, as it were. The logic being that if you encounter pathogen once, you're probably going to encounter that pathogen again at some point. So you want to really increase the chance of encountering that pathogen. So by having more of that specific B cell around, you're going to encounter that pathogen sooner the next time you see it, and the response will be faster. So that's why there's immunological memory. Things that you've been exposed to before, your immune system remembers and will mount a stronger, faster response to it the second time. So in the primary encounter, the antigen meets the specific the specific B lymphocyte that is coded for it. In this case, it is this middle one. Right? This forms clones. Some of the clones become plasma cells, which make 2,000 antibodies a second. Some of these clones become memory cells. So now you have a whole bunch more of these, so the next time this little red dot appears, you will be ready for it. So, if you've never encountered this pathogen or this antigen before, then what's going to happen? This thing has to get into your body, it has to proliferate a little bit, it circulates around, and then it has to come into contact with maybe the one or perhaps the two B lymphocytes that are coded specifically for that antigen. This usually takes a number of days. And then, once it happens, then those have to clone, and then those clones have to become activated, and then they have to grow into plasma reticulum and turn into plasma cells and then start making antibodies. And then you've got to get enough antibodies to actually eliminate the antigen. So 3 to 6 days lag before this whole thing starts, and you don't get the peak levels of antibodies until 10 days. And this is one of the reasons why most, especially viral infections, last about 10 days. This also explains why you're infectious before you have any symptoms, because it's this immune response that's causing the symptoms. And you still have symptoms after the antigen or the pathogen is eliminated, and you're no longer contagious. The antibody levels then decline, but they stick around long enough to protect you against any further reinfection. I think that's a pretty important part. Now, the next year or whenever, you get a re-exposure to the same antigen. Now, you've got thousands of these memory cells that are coded for that antigen. You're going to get an encounter probably within an hour or two rather than days, because there's just so much more of them, so many more of them. And they're going to start making their antibodies almost immediately. And there'll be more of them cloning, and more of them making plasma cells, and more of them make more plasma cells making antibodies. So antibody levels peak really quickly, right? And so really the secondary response, the second time that you encounter this pathogen, you mount a much more efficient and stronger response, and you probably will not get ill. So you just get more of the same thing that the primary response gets. So if you look at it on the graph, excuse me, the primary response happens, and then you get the second exposure, and the next one is much stronger, much faster. This is a primary exposure that happens kind of to a different pathogen. Okay, so humoral immunity is a very important thing. And you get humoral immunity when you have antibodies. Now, you really can get this in two ways. One is a natural way, which means that you encountered the pathogen, so you have an infection, you have the thing, or you can get this artificially. Now, this is a fairly new idea, but it's something that we all, especially in North America, have come into contact with. Instead of giving people an infection in order to have the immunological memory and the antibodies to it, you can give just the antigen, either attached to a dead pathogen or to a pathogen that has been altered so that it can't reproduce. And these things are really, it's vaccination. So the whole idea behind vaccinating is to give that primary response before you're actually encountering a pathogen. So when you do encounter the pathogen for the first time, your response is the secondary response rather than the primary response, and it happens almost immediately. So it's a very sound idea, and it works. We call that artificially acquired. So we don't get the symptoms of the primary response, right? So they end up, it ends up working, not as strongly as if you actually have fought off the infection yourself, but nevertheless, much better than having never read it. Okay, there's another way that we can get it, because the antibodies are what does the fighting. So because the antibodies are what does the fighting, you can have protection by just getting the antibodies and not actually having your B cells clone and make plasma cells and then making the antibodies. You get no memory cells this way, but you get protection. And we call this passive uh, immunity. And it offers a measure of protection in the short term. It's limited, but it's very useful. Now, there's naturally acquired and there's artificially acquired methods of getting this. The naturally acquired is when a mother has been exposed to a pathogen while she's pregnant, and then her immune system fights that pathogen, creates antibodies against that pathogen, and those antibodies cross the placenta and enter the fetal body. So now the fetus's blood is full of antibodies that are made by the mother's immune system. The logic behind this is that when the baby is born, the baby is probably going to be born into the same environment that the mother is in, and that environment will probably have the pathogens that the mother is actually actively fighting. So giving the babies these antibodies before they're born actually offers the baby a measure of protection against those pathogens until its own immune system can encounter the pathogens and mount the response. It's a very good way. Now, mother's milk will also pass these antibodies to the baby as well. So we can keep this going for the infancy of the child, and it's a very useful thing. Now, the other way of getting passive humoral immunity is artificially. So a doctor is going to inject you with something. Basically, these are called serums. Gamma globulin would be the major one. Tetanus shots fall into this category. Snake venom falls into this category. What they do is they expose usually another animal, usually a large animal like a horse or something, to the antigen. Often it's the pathogen. The animal has the immune response. You take blood from that animal and you centrifuge it down and you take off the antibodies and you make a serum from that. And then when you inject those antibodies into a person, that person acquires protection against that antigen because of the antibodies that the person got. They don't get memory, but they get protection. You've probably seen them milking rattlesnakes and cobras and things where they are collecting venom. What they're doing is they give that venom in very small amounts to animals who then have an immune response against the antigen that's in the snake venom. They collect the antibodies from that animal's blood. They make a serum with those antibodies, and then if you get bit by that type of snake, you get injected with the antibodies, but with the serum, and then those antibodies will get rid of the antigen of the snake venom and protect you. Tetanus is like this. Various other things are like this. It's not really vaccination, but it is a passive protection through antibodies. The problem is you get no memory. So, and when the antibody titer, when the amount of antibodies goes down, then the protection is diminished, and that's why you need booster shots of this all the time. So really, we can look at it in humoral immunity as getting it two ways, active and passive. Okay, active is when you make the antibodies yourself. You get plasma cells and they make antibodies. And this happens because of a challenge from the antigen. There's naturally acquired when you get the infection. There's artificially acquired where you are injected with the antigen in a form that will not give you an infection. So either dead or some sort of attenuated pathogen that has the antigen on it. So this is vaccination. This is the only one that's called vaccination. Or you can get humoral immunity passively, which means that you're getting antibodies made by another individual, maybe not even of the same species, but you are getting their antibodies from their active immunity. It's now passive to you. Naturally happens when you get it from your mother, either across the placenta or through mother's milk, and it offers a level of protection for babies. Or you can get it artificially by getting a serum of those antibodies, of those globular proteins, of the globulins against that thing, and that offers you a measure of protection. So things like tetanus shots or antivenoms, that sort of thing, are all passive, artificially acquired humoral immunity.